So the next problem is finding the maximum and minimum. This also follows divide and conquer strategy. The problem is to find the maximum and minimum items in a set of n elements. For example, consider the following list. The list has 7 elements. We have to find out the mid element. So basing on this mid element, we will divide the list into 2 sublists. The left sublist will have the values from 0 to mid, and the right sublist will have the values from mid plus 1 to high or n. Let's divide this list. We again have to divide the list recursively, finding out the mid again. The second step is to conquer. We have to find out the maximum and minimum element in each sublist. And the third step is combine. We have to combine the sublist and we have to compare for the maximum element and minimum element. So the 3 steps are divide, conquer and combine. Let's write down the maximum and minimum element of each sublist. As each sublist has one element, that will only become the maximum element and minimum element. Now we will combine. So max returns the maximum of the combination and min returns the minimum of the combination. Combining the final 2 sublists, we have max equal to 18 and min is equal to 1. So this is the solution to the given example. Now let's write the algorithm for max and min. Algorithm max min, and it takes the arguments I, j, max and min. I is the lower bound, j is the upper bound, and max is a variable containing the maximum value and min is the variable that is having the minimum value. So the first condition is if I is equal to j, that means the list has only one element. That element will only become the maximum value and the minimum value. So when I equal to j, max equal to min equal to a of I. Else if the list contains 2 elements, then I is equal to j minus 1. Then what we have to do? We have to compare those 2 elements to find out the maximum value and minimum value. If a of I is less than a of j, then max will contain the value of a of j, min will contain the value of a of I. Else, that means if a of I is greater than a of j, max will contain the value of a of I and minimum will contain the value of a of j. So we are comparing the two elements, and one will be maximum and one will be minimum. Okay. Else, that means when the list has more than two elements, we have to find out the mid element. Mid is calculated by I plus j by 2. So basing on the mid value, we will divide the list into two sublists. We will call max min function recursively. The first list will have the range from I to mid. Maximum value is stored in max and minimum value is stored in min. The second list will have the range from mid plus 1 to j. We will take two variables max 1 and min 1 to store the maximum value and minimum value. Okay. Then the last step is to combine. That is, we have to do the comparison between the two lists. So if max is less than max 1, that is max 1 is greater than max, then maximum value will be max 1. If min is greater than min 1, then minimum value will be min 1. Like this, we'll do the comparison and find out the maximum value and minimum value. Let's trace out this with an example. So this is an example. The list is having 4 elements. Here we have n greater than 2. So the first step is we have to find out the mid value. Mid is calculated by I plus j by 2. This is I, this is j. We have to call recursively max min function in both the lists. Let's write out the recursive functions. 0 to mid, max, min. The second function is min max. 2, 3, max 1, min 1. The list has two elements 49, 86. I, j. Here I equal to j minus 1. That means the list has only two elements. So what is the condition? If the list has two elements, we have to do the comparison between a of I and a of j. We have to find out the maximum value and minimum value. Here a of I is equal to 49 and a of j is 86. We have to compare a of I with a of j. If a of I is less than a of j, then max equal to a of j. That is 86. Min becomes a of I. So coming to the second list. So this is the list. It has two elements 55 and 24. I, j. I equal to j minus 1. The list has two elements. Again we have to compare the two elements. A of I is 55 and a of j is 24. Here a of I is greater than a of j. Therefore max contains the value of a of I and min 1 contains the value of a of j. So after calling recursively max min function, we have to combine the results. Max equal to 86 and max 1 equal to 55. We have to compare max with max 1. We have to compare minimum elements also. Min equal to 49 and min 1 equal to 24. Therefore min equal to min 1. This is how we'll find out the maximum value and minimum value of a list. Let's analyze the time complexity of this algorithm. Time complexity has three cases. If the list has only one element, we are doing zero comparisons. That element will only become the maximum value and minimum value. Hence, the time complexity is 0. If there are two elements, we are doing one comparison. We are finding out the maximum value. The other element will become the minimum value automatically. If the list has more than two elements, we are dividing the list into two sublists. And we are comparing the two elements for finding the maximum value and minimum value. T of n by 2 is the time complexity of the sublist. By combining all these, T of n is equal to 2T of n by 2 plus 2. Expanding T of n by 2. Now the k minus 1th term will be like this: 2 power k minus 1 T of n by 2 power k minus 1 plus 2 power k minus 1 plus 2 power k minus 2 plus up to 2 cube 2 square and 2. Now this term from 2 power k minus 1 to 1, this is nothing but geometric progression. It can be written as sigma I is equal to 1 to k minus 1 2 power I, and the result will be given by the formula A into r power n minus 1 by r minus 1, where I is the first term, r is the rate, n is the total number of terms. So expanding this and substituting the values, will have the value as 2 power k minus 2. So this is the equation 1, and we have to substitute this value in equation 1. Substituting the value of geometric progression in equation 1, we have Now let us assume that the size of the list is in the power of 2, that is n equal to 2 power k. Substituting n is equal to 2 power k in our above equation, we have the value of t of 2 is 1. So we have to write 1 here. Hence the time complexity of the algorithm is the order of n.